In this video, we are required to find the area of the shaded region. So this is the shaded region, and from here, this line cuts through, and from here to here is 10, from here to here is 10, while from this point to this point is 18. With that, what is the area of the shaded region? This is the center of the big circle, and this is the center of this small circle. Now let the center of this big circle, let it be M, and let the center of this small circle be N. As you can see, this line here extends and passes through these two centers. Okay, also this line extends to pass through center M, like that. Now let the radius of the big circle, let it be capital R, and let the radius of the small circle, let it be small r. Now, since from this point, from here, from this point all the way to the end, it is the radius of the big circle. As you can see, this is the center of the big circle. So from here to here is capital R. Whereas from here, if we are to draw a straight line, straight vertical line through center of the small circle, so from here to here is small r. If from here to here is capital R and from here to here is small r, that implies that mn is equals to this capital R minus this small r. Okay, so let's call this equation 1. Now, that implies that the diameter of the big circle is 2r. From here to here is 2r. And the diameter of the small circle from here to here is 2 small r. Now, as we can notice, the diameter of this big circle is equals to the diameter of the small circle from here to here, which is 2r plus 18 from here to this point. Hope you can notice that. So the diameter of the big circle, which is 2r, is equals to the diameter of the small circle from here to here, 2 small r, then plus from here to here, which is 18. Since they are all divisible by 2, let's divide through by 2. So here we are left with r is equals to small r plus 18 by 2 is 9. So let's call this equation 2. Now here, when we take r this side, we shall have capital R minus small r being equals to 9. Therefore, from my equation 1, which was mn is equals to r minus small r, now we have got r minus small r as 9. So we replace, therefore mn is equals to 9. Now next, let me first of all call this point here. Let me call it point P. Now I'm going to connect point P to point M, M to N, and P to N to come up with a right angle triangle, since this is 90 degrees. So here it is. This is 90 degrees at point M. As you can see, PN from here to here, this is center N of the small circle, up to the circumference at point P is the radius of the small circle. So this PN is small r. We already know that MN, we got MN as 9. So from here to here, is 9. And we already know that from this point to the center M is the radius of the big circle. Okay, so if from here to here is capital R, and we know that from here to here is 10, that implies that PM will be equals to capital R minus the 10. Okay, and from equation 2, we saw that R is equals to, see, R is equals to R plus 9. Okay, small r plus 9. So we're going to replace this for this. So we shall have PM being equals to R plus 9 minus 10. Therefore, PM is equals to R minus 1. So from here to here is R minus 1. So now if we are to focus on triangle PMN, which is like this is 90 degrees, this is PMN, PN is R, PM is R minus 1, and MN is 9. As you can see, it's a right angle triangle, so we're going to use Pythagoras theorem to solve. So A squared plus B squared is equals to C squared. And our A is 9, so 9 squared plus our B is R minus 1. So R minus 1 squared is equals to our hypotenuse, which is R. So R squared. Now from A minus B squared being equals to A squared minus 2AB plus B squared, this here will become 9 squared is 81. So plus, when you expand this in this form, this will become R squared minus 2R plus 1. So this is equals to R squared. Now when this R squared comes this side, it will become negative, so they cancel. So we are left with 81 minus 2R plus 1 is equals to 0. 81 plus 1 is 89. So 89 minus 2R is equals to 0. We make 2R the subject, so we shall have 2R is equals to 89. Divide both sides by 2, and therefore R is equals to, 81 plus 1 is 82, not 89, sorry. So this is 82. So 82 divided by 2 gives us 41. Therefore, radius of the small circle is 41. Now that we have radius of the small circle, let's substitute R in equation 2. Our equation 2 was R is equals to small r plus 9. And we have got small r as 41. So capital R will be 41 plus 9, which gives us 50. Therefore, the radius of the big circle is 50, while the radius of the small circle is 41. So now we can find area of the shaded region when radius of small circle is 41 and radius of big circle is 50. So area of shaded region is equals to area of big circle minus area of small circle. Okay? We know that area of a circle is given by pi r squared. So for this big circle, it will be pi, radius is capital R squared, then minus pi, radius of small circle is small r, so pi r squared. We factor out pi since it's common. So we shall have A is pi into capital R squared minus small r squared. So area is equals to pi into Remember our capital R is 50. So 50 squared minus, and our small r is 41. So minus 41 squared. So area is equals to pi into 50 squared is 2,500 minus 41 squared is 1,681. So area is equals to pi into this minus this gives us 819. So area is equals to pi is 3.14. So times 819. So our area therefore becomes 2571.67. So this is the answer in square units. So this is the area of this shaded region here. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about the video in the comment section down below. If you have alternative approaches, you can also share with us in the comments. Thank you. Please subscribe. It's completely free of charge. It's a humble request. It's the only way you can help me. Thank you so much. See you in the next video.